humanity is at a precipice, that we are not able to control the proclivities that we have towards destroying ourselves, that we won't have a future. And so the only thing we'll have is this will.
Hello and welcome to A Theory of Everything. I'm Luis Razo, the director of ASEM and host of this channel. Today we have as a guest Brian Keating. Professor Keating is the Chancellor's Distinguished Professor of Physics at the Center for Astrophysics and Space Sciences at the University of California, San Diego. He's a public speaker, author, inventor, and an expert in the study of the universe's oldest light, the cosmic microwave background. He's also an up-and-coming podcaster who has interviewed some of the most influential public intellectuals in the world. We talked about his recent book, Losing the Nobel Prize, wherein he describes a personal journey that brought him to the point of tasting the Nobel Prize, but then losing it. We tried to contextualize his book and his journey against the background of humanity's quest for a so-called theory of everything, and agreed that long-term human survival is a wise thing to pursue, which of course is the central theme of our work on this channel. We also talked about the absolutely disproportionate impact that the Jewish people have had on physics and on virtually every branch of human activity, and what Professor Keating thinks might be the root cause of this. We weren't able to discuss many of the topics I would have liked to explore, but maybe we'll be lucky enough to have him on again at some point in the future. For your convenience, I've placed a timestamp to our discussion in the video description. I hope you enjoy, and thanks for bearing with me as I continue to improve with these exchanges. Professor Keating, welcome, and thank you so much for doing this.
Oh, it's my pleasure, Luis. Nice to be with you.
Thank you very much. It's my pleasure. So you've written a wonderful book. Before we get into the details of the book, I'd like to ask you to contextualize our conversation and the book by giving us a quick kind of overview of where we are as a species according to science, beginning, for example, with the Big Bang and where we are now. If you can give us a 30-second or 1 minute, 2 minutes of
30-second history of 13.8 billion years. Sure, no problem, Luis. I thought I'm supposed to give the homework assignments here. So I study the origin and evolution of the universe, which is called cosmology, but most people don't realize there's another very similar sounding effect or subject called cosmogony, which involves the study of the origin of the universe. So cosmology technically does not cover the way in which the universe itself got started. In other words, it doesn't discuss the initial conditions of its own founding any more than, biology is concerned with the origin of life itself. And so it's really more concerned with the evolution of cosmological systems according to the laws of physics, which is interesting because cosmogony, the story of the origin of the universe, is really a much older subject and a less technical or less precise field of study, meaning that it has relied traditionally on perhaps folklore, religious text, speculation without evidence, some conjectures, philosophical arguments from first causes, things like that. And it really is sort of foundational. And it's funny how little we teach our students about the genesis of the universe, if you will, if there was indeed a single genesis, and that's a hot topic in physical cosmology. But also, we really ignore the philosophical underpinnings, which to me make the field as interesting as it could possibly be. So I do study using technology tools, telescopes, detectors, how the universe has evolved. And we're trying to push back our understanding. Currently, our understanding goes back 13.8 billion years. to the origin of the elements in what we call Big Bang nucleosynthesis. But it's not necessary that the origin of the elements was preceded by the origin of the universe itself. It could be that the universe is indeed eternal in a certain sense, cycling between successive expansion and collapse cycles, for example. It could be our universe was singular. There's one universe. It came into existence once. Or it could be there's an infinite number of other universes, and they come into and out of existence almost continuously in what's known as the multiverse. So there are these three, very fascinating possibilities that in some sense are as old as time itself, because we've thought about notions of a singular origin. We've thought about notions of the eternal universe and a cyclic universe since as old as since the beginning of time. And so I think it's quite fascinating that we have such an ability to study technologically these things for the very first time.
Okay, wonderful. And if I remember correct, the Earth is about 4 million years old, and the human species is
4 billion years old. Billion years old.
4 billion years old. I'm sorry, of course. 4 billion years old.
Yes.
And the human species is, in its current form, maybe 100,000 or 200,000 years old. And where does your book fit into this 100,000-year-old history? What's happening in the background of your book?
Yeah, so the book Losing the Nobel Prize is really a memoir of what it's like to be a scientist, a younger scientist, and try to seek and strive and not to yield, as Tennyson would say, in the quest to understand what the universe is all about, perhaps driven by a more base, a more venal, if you will, a desire at first to want to win the Nobel Prize, in addition to wanting to understand how the universe came to be. And that's just part of my honesty in the book, is describing what I was motivated by, in addition to wanting to understand how the universe came to look the way it does. What I try to study in the laboratory and the telescopes that I build with my colleagues around the world on all 7 continents is how the universe could reveal itself through invisible forms of light or radiation. And furthermore, if the universe did experience a singular origin, if the universe did have a cyclical kind of behavior, the pattern that we see in the universe's oldest light, called the cosmic microwave background radiation, or 3 Kelvin radiation, that would be imprinted with, encoded, encrypted with information about its singular origin or lack thereof. And we call that a type of polarization. The light has a certain ability to be oriented in different structures and different patterns that we can divine, if you will, using ultra-sensitive telescopes at the bottom of the world, in the case of the South Pole, Antarctica, where my story in Losing the Nobel Prize takes place, or on the tops of the Andes Mountains in Chile at 5,200 meters above sea level. We're trying to build the world's most sensitive, largest detectors ever made in order to go after this singular question of how the universe came to have the appearance it does today. But there's no guarantee. We may come up empty. And in fact, the title of the book is an allusion to the fact that we did hope and were positioned to win a Nobel Prize. But, there's no spoiler alert needed, because we didn't end up detecting what we claimed we had detected. Instead, we detected an imposter, an interloper. So you ask, where does it fit in the 100,000-year history of the human species as we are today as Homo sapiens? Well, Homo sapien means, someone who knows that they know, sapient, conscious. And we are now able to think not only ideas about how we came to be, but also to test them using technology. And perhaps for the first time, although maybe not, be able to understand how exactly the universe came to have the appearance that it does have.
Excellent. When I read the book, I was struck by 2 different lines, if you were. One is a more personal line, and the other is kind of about the history of attention between those who would have humans at the center of existence, a physical existence, versus those who would say that humans are absolutely insignificant. I think you called it the Great Debate. Can you run us through that aspect of the book? I found it so fascinating. starting with Galileo and
Yeah. So,
Copernicus.
right. Yeah. It's fitting that you mentioned it because this year, 1920, 2020, marks the 100th anniversary of what was originally called the Great Debate. And that is a subject of a section of the book as well. And that debate took place in Washington, D.C., in the halls of the United States Capitol, basically to settle the question once and for all of whether or not the Milky Way was a galaxy. So we take it for granted that we live inside this island of hundreds of billions of stars called the Milky Way galaxy. But back then, it wasn't known if were other galaxies in addition to the Milky Way, or if our galaxy was the entirety of the universe itself. They called that the Great Debate. That was in 1920, and it wasn't settled in 1920. They never really came up with a definitive answer until Hubble, famous Edwin Hubble, discovered that the universe had other galaxies within it, and we could measure the distances to these galaxies, and they were larger than the size of the Milky Way galaxy itself. And then a few years, and that was in 1923. So the so-called Great Debate wasn't settled until 3 years after the actual debate itself. But I claim there were actually preceding debates, at least two other debates before that. The first one by Copernicus and Galileo, namely whether or not the sun goes around the earth as was perceived and claimed for literally thousands of years beforehand, or whether the earth instead is a planet and goes around the sun. And that took place in the 1600s and was really not definitively settled until Galileo observed the moons of Jupiter, which were clearly orbiting the planet Jupiter, not the sun or not the earth, but then it was almost inconsistent. You could not hold that Jupiter was orbiting, sorry, the moons of Jupiter were orbiting around the Earth. They certainly weren't. And so that caused a lot of dismay. But actually, Galileo was famously put on trial by the Inquisition much later in 1634 after publishing a book called the Dialogo. And that was really trying to settle the debate once and for all in favor of Copernicus. And that's a subject of another talk. I do speak about that in the book. But really, the next great debate that took place after Galileo discovered the moons of Jupiter and that they clearly weren't orbiting around the Earth, an astronomer named William Herschel in the 1700s made a map of the Milky Way galaxy and put the Earth at the center of that structure, rather the solar system. By then, it was realized and accepted that the sun was the center of the solar system, but it wasn't known where the center of the galaxy was. But he made a map of the galaxy and put the sun at the center of that map, more or less. So it was almost as if, well, we're not the center of the solar system, but we could at least be the center of the galaxy. Later on, we realized after the Great Debate that I discussed in 1920, we realized that the center of the Milky Way was actually quite far away from where we are located in the outer disk of the Milky Way galaxy. And then furthermore, people began to realize that we're not even the only galaxy there is. So that was another debate. There's literally hundreds of billions of other galaxies, each containing hundreds of billions of other stars. And so it's quite fascinating to then make the next logical leap and say, well, if we're not the center of the solar system, we're not the center of the galaxy, we're not the only galaxy, we're not the center of the universe. And so that was Hubble's discovery that the universe is expanding from every observer's perspective, meaning that the universe was smaller in the past, will be bigger in the future, but we're not the center of it at all. That's the fourth great debate. And then the fifth great debate is now maybe we're not the only star, planet, galaxy, maybe we're not the only universe. And that's the current great debate. But I don't think we're reaching the end of the great debates. I think there could be great debates about the laws of nature, the the underpinnings of quantum mechanics, things you're interested that I know. Are there one set of laws that apply in our observable universe because we're here to observe it? Are there other universes in time, in space, in time and space, in dimension? And these are all fascinating, great debates that I claim will continue for the future. You can imagine great debates. Is it true that carbon is the only way to form a living organism? Some say you could get all the properties of life using silicon, namely computers can simulate life and maybe even simulate us right now having this conversation. So it's fascinating to contemplate. All these debates are part of this grand tradition of science to inquire, to test, to refine, and hopefully come up with new ideas to test measure and refine.
Fantastic. Well, within this these great debates, or the current great debate, or the tension between these two ways of thinking about human existence, there is this quest to unify general relativity with quantum mechanics. They're speaking two different languages, and you've had some very, very fascinating discussions recently with people like Eric Weinstein and Wolfram about this attempt to unify general relativity and quantum mechanics. Can you tell us where do these conversations fit into this tension between whether or not humans exist at the center of reality or not?
Yeah. So that I came to after the book, obviously. This is something I've been doing in this 2020 time period in honor of the 100th anniversary of the Great Debates. But I found it quite interesting to engage with people who think about the quantum nature of the universe. There are some who say there is no need for a quantum theory of gravity, a so-called theory of everything that would unify all the lower or higher energy or higher strength forces of nature, the two nuclear forces and the force of electromagnetism. We know that electricity and magnetism are unified in the electromagnetic theory that was known in Maxwell's time. We know that the weak theory and electromagnetism are unified in the electroweak concept. There's grand unified theories that attempt to unify strong force with the electroweak force and creating different mathematical representations and moving away from all physical reality. In other words, you can model these things purely based on their mathematical properties. And the question is, why is gravity so different and distinct? Why is it impossible, seemingly so, to just take the same procedures that we've used for the nuclear forces for electromagnetism and apply that to gravity? And there's many different approaches to it, which means that someone's got to be wrong. If somebody's right, then a lot of people are wrong. But there's also a question of, is it even necessary to unify gravity with quantum mechanics? And there's two realms in which quantum mechanics and gravity could be required to be unified. One is at the center of a black hole, where there's a so-called singularity. We don't really understand singularities. We don't understand the properties of something that is infinite that then tapers to something very gracefully that's finite. So for example, near the center of a black hole, inside at the very center of it, we have no idea what that matter and space-time are even like, but it could be that the curvature of space-time is infinitely curved. In other words, the radius of curvature is infinitesimal. But we know at great distances, or even at not so great distances, that if you replace the sun by a black hole, we would notice it gravitationally for basically as long as possible. We keep orbiting around the sun, and so do the other planets. And so the effects of a black hole at distances much greater than the so-called Schwarzschild radius are basically irrelevant to classical dynamics that we observe. So how do you go from an infinite gravitational potential, infinitely deep, to a finite gravitational potential? How do you go from infinite gravitational forces to finite gravitational forces over a very short distance? It's very bizarre. So it's safe to say we don't understand that. That's region one, where you'd like to have a quantum description of gravity. And I think you can safely say that that wouldn't necessarily mean that you have a theory of everything. If you understood, it might mean that it might require that you have a theory of everything, but it might not. You might have something that only applies to black holes, and you might be able to do it purely classically, in other words, not need quantum mechanics. The other regime in which you need to have quantum mechanics unified with gravity, according to many purveyors of these theories, is in the extremely early universe. If there is a singularity of space-time, where the universe comes into existence spontaneously ex nihilo from nothing, it may be, and it seems to be required in that circumstance, that the universe has some way of making gravity play nicely with quantum mechanics, because the size scale of the universe, the properties of space-time itself may be quantized. And so we don't understand how that could behave. Now, I said two things. One is that we need to do that if there was a singularity in the case of the black hole, and or if quantum gravity is necessary to describe a black hole. Of course, we may never be able to detect that, but also it may not be necessary for the universe to have undergone a quantum event at the origin of our current observable universe. In other words, if our universe came from a preceding universe's collapse, that collapse doesn't have to collapse to an infinitesimal singularity. There are people working on, Paul Steinhardt and collaborators, on a purely classical bouncing cosmology, where the universe goes from from a pre-existing state in a prior universe, perhaps an infinite number of those universes, and collapses down, but not necessarily to a point. And that's very important, because in that case, you don't need quantum gravity either. So I have found it very interesting this summer to think about whether or not we need a theory of everything, or whether it's just kind of this extension of, as you said, combining, this notion that we are special in some sense and that we understand things relative to our existence, that maybe we don't need a theory of everything. I don't mean that people should stop thinking about it. But that, combined with some other observations I made this summer, including the proliferation of models of theories of everything, led me to believe that it's not an open and shut case that we have to demand a theory of everything exists.
Very interesting. Well, I'd like to connect these same questions, because they're so abstract and apparently removed from everyday human concerns. So I'd like to connect them, or try to connect them, back to your book. And the other half of your book is a very personal journey. And at the end of this personal journey, where you talk about losing the Nobel Prize in a very exciting way, you end with the concept of an ethical will. And you say that this is probably the most important lesson to take from your experience, and that you'd like to pass on. In this same line of reasoning, trying to connect these two, I've found an enormous gap between scientists, and especially physicists at the cutting edge, and things that really matter to humans. There's this enormous gulf. So as an outsider, I always like to say, wait a minute, we need to connect the two. Especially telling in this regard is your recent conversation with Jim Simons. In the final minute of the podcast, you ask him if he could send a message out into the universe for future generations, or for other types of living beings, what kind of message would he send? And I was very struck, and I very moved, and agreed very much with his answer. He said that the most important science is political science, because if we don't change the way things are now, we're going to cease existing. So how do you connect your ethical will with these big questions, or do you connect these moral questions with these scientific questions?
Yeah, it's become a very big, excuse me, it's become a very big topic of consideration for me as I think about, upcoming projects and these conversations that I have with these luminaries, ranging from Jim Simons, Freeman Dyson, and then younger folks like Eric Weinstein, et cetera, Noam Chomsky. What am I going to derive from them that is not already known by simple Wikipedia searches? So you could be, I remember once, realizing that you could actually pass any test in undergraduate physics if you could just memorize, 5,000 different facts, like different constants, different equations, and you may not be able to derive them, but you could basically effectively pass any undergraduate first level physics classes. And that made me think, well, what's the difference between a computer, and at that time Wikipedia didn't exist, but effectively Wikipedia has all these answers to basic questions about knowledge. And science itself, the word science, you can correct me if I'm wrong. I assume that you understand Latin languages better than I do, because I don't understand them at all. But the word science derives from the word knowledge, scientia, in Latin, is meaning knowledge. But what it does not mean is wisdom. So Wikipedia has a tremendous amount of knowledge, but it has zero wisdom because it's just a repository of facts. So I started thinking people are so focused on things like artificial intelligence. What we really need is artificial wisdom, or maybe even more natural wisdom. And so how can you do that? And I started thinking about it in terms of legacy as I explored in my book, but really I've been doing it more lately. What kind of legacy do you want to leave that's not tangible, material? You know, Jim Simons is a wealthy billionaire. I don't need to know how he's going to leave his actual dollars. He's going to donate almost all of it, it turns out, to scientific charities. But the question of whether or not he's going to leave ethical wisdom is much more interesting to me as a legacy. And as you said, you know, he basically feels that humanity is at a precipice, that we are not able to control the proclivities that we have towards destroying ourselves, that we won't have a future. And so the only thing we'll have is this will, or we'll have this information that will carry on into the future, but it won't necessarily provide anyone, you know, to anything of value, because we won't be here to kind of glean it. So part of the presumption of leaving a will is that you have some heirs, or you have some people that will benefit from your money or from your gifts or from your wisdom. And so I agree with him. And actually, Eric Weinstein's expressed the exact same sentiment in a different podcast that I did with him, that he's very concerned that we actually are on the precipice of destroying ourselves much more quickly than I think Jim Simons is. Namely, that the power of the atom, the power of the cell, you know, to do a biological, you know, to affect us biologically through this awful pandemic that we're seeing, but also the atom and then the bit, you know, so it's kind of like the cell, the atom, the power of the atom bomb, the cell, the power of DNA to potentially do harm, and CRISPR and modified DNA, et cetera. And then the power of the bit, the computer, to perhaps have runaway artificial intelligence scenarios that people like Elon Musk and Max Tegmark have talked about. So these three things really could conspire in some awful scenario, according to many of these gentlemen. But the question of, will we allow it to happen? And can we be wise enough by thinking about our ethical will? I claim we can avoid suicide, you know, that we can avoid killing ourselves if we think about how meaningful it is to give something to the future, whether it be monetarily, whether it be technologically, or whether it be wisdom. I think by doing that, we will kind of have a little bit of an insurance policy against committing suicide, in the sense that our civilization could go extinct. And so I found that to be kind of a new mission that I'm trying to undertake, rather than just saying, well, here's how many megatons the bomb is, and it could destroy this city or whatever. No, think instead of like your children, your children's children, the future of the civilization of the human race. I think that can do more than just raw numbers about the destructiveness of the technology that we've unleashed, without perhaps having the wisdom to control it fully.
Well, very true, very true. So I've always proposed, as a first principle of every branch of human knowledge, is the idea that it's better for humanity to survive than it is for humanity to go extinct. So I think any and every idea can and should be judged according to this barometer. So for example, if you have two competing theories of everything, or two competing theories of how to reconcile quantum mechanics and general relativity, if one of them leads us to a more promising way, or a wiser way to live as a species, then that particular proposal is obviously better than one that has nothing to say about that. I think I'm reminded of Richard Feynman, who said something to the effect that stories and how we tell stories and how we interpret math in physics matters. I think he was talking in particular about the Dirac picture versus the Schrodinger picture versus the Heisenberg picture, and that any good physicist always has these multiple interpretations in his head, because he never knows where the next breakthrough is going to come from. Do you think this is a fair assessment of how to interpret the various theories of everything, or one of the various ideas and projects that we're taking on now as a species, that the priority should be looking for ways to not bomb ourselves out of existence. Does that seem reasonable?
Well, it is and it isn't. I mean, I don't necessarily believe that, there is a panacea where, by merely even contemplating our ethical will or contemplating mathematics, etc., can really confer wisdom. Thinking about this pandemic, I don't know how it is over there in Europe necessarily, but we've had a lot of different discussions about this, which have really impacted and touched upon the role that science and scientists can play in the managing of something global that has potential threat to a large fraction of humanity. And I've kind of been a little bit dismayed in that, exactly to the contrary of Jim Simon's advice, the politicians are now completely abdicating their authority to scientists. Now, that's kind of unusual because I'm a scientist. You'd think, oh, I'd like to have a lot of power. No, we don't elect scientists to be our politicians. We elect politicians to seek advice and counsel, and you are a management expert, as I understand it. So you don't want, if you're managing a soccer team, you don't want the players to manage the soccer team. If you're managing a factory for Apple, you don't necessarily want the computer programmers to manage the company. They have different skill sets. They have different optimization functions against which they try to find a perfect equilibrium. And so I'm a little concerned when I see, people deferring complete authority politically, to set policy, political power to scientists. I think they should listen to scientists, but people should know that scientists is very iterative and self-correcting, hopefully, but it takes a lot of time. And I think people are demanding. I mean, imagine if you demanded that you had, a quantum computer that would be a smartphone, that's based on quantum computing, and you demanded it has to be here, or people's lives are going to be at stake, or people's, bank accounts. You couldn't encrypt any transaction, and so you demand. The world's in chaos. And so you demand physicists come up with this. And then you ask the physicists to determine, like, well, who should have it? Should a terrorist have quantum undecryptable self? So you get into all these problems. But I think I think trusting a little too much in science can be a false, based on a false premise.
Interesting. You're right. That is kind of surprising, but I see your point. I think it's a valid point. At the same time, it's also a little scary because to entrust human existence to politicians also seems like a challenge at the very least.
Yeah, okay. Certainly, you have to strike some balance. So you hope that you have, wise leaders who are, who will take advice and counsel and won't be driven surely by, by the, the desires and the trappings of power.
Very interesting. I'd like to transition now to, well, along the same lines, there has been an incredible contribution, a disproportionate contribution to various branches of science by the Jewish people. And I have a great admiration for the Jewish people. You yourself are Jewish, of course. I'd like to ask you where the role or how your identity as a Jewish person fits into your personal life and into your work, keeping in mind, the great names that in science, and not only in science, but in virtually all branches of human activity, beginning with the Old Testament up through the cutting edge of theoretical physics.
Yeah, it's very interesting because when you think about how science has been influenced by the scientific method, which I said before is the cornerstone of progress in science. The Jewish method, as I call it, is a sort of a scientific method in Judaism, which is also adversarial. So you're probably familiar with the most famous book in history. I always joke, I'd love to have 1% of what God had for his book sales on the Bible. The Bible is the most important book to the Jewish people in Judeo-Christianity. However, There's a second book, which is almost equally important, and that's called the Talmud. The Talmud means teaching or method of teaching, and it's 2,700 pages long. So if you read one page a day, it takes 7 years to complete this book. And people do that. They read one page a day. And the way that the organization of the book is structured is via argumentation. So it will take a passage from the Old Testament and you'll have people argue about it. So for example, most famous one is an eye for an eye. So, let me ask you, Luis, do you think that's meant to be taken literally? Like you take out my eye and then I go in and take out your eye. Do you think that's meant to be taken literally? I'm curious.
No, obviously not. No.
Right. So because they, even the first sentence that they say in the Talmud, there are all these rabbis and scholars debating it. Like the first thing they say is this was never taken literally, because it's impossible to do the exact amount of damage to your eye as you did to my eye. And so, because you're going to have different pain. Like if you hurt my eye accidentally, I didn't know when you were going to hit my eye and maybe I passed out, but I'm going to take out your eye. You're going to have a lot more psychological trauma. So it was actually meant monetarily, and it was meant as an equalizer to say that a king's eye, if you took out the eye of a king and you were a slave, you were put to death in many ancient cultures. But this was meant to say, no, you would be forced to make recompense financially. And so all these debates go back and forth. Now you can argue that's still not good, or whatever. But the point is, the scientific method of the Talmud is adversarial. So one rabbi will say, no, it meant literally, take out the eye or whatever. No, one said, no, it meant that if you hurt your slave, you have to pay for his eye. Of course, unfortunately, they had a form of slavery. It's more like indentured servitude. We don't have to get into that, right? It wasn't like we had an awful treatment of Africans and Americans in the South in America. It's not related to that, but the notion of like what do you owe your people that work for you? How do you owe people that you're managing? And what about you? Because people would volunteer themselves to be what we call slaves, but really it's a form of servant. And so how do you treat them? If you had a pillow, but you only had one pillow, you had to give that to your servant. You could not keep that for yourself to sleep on. So all these things are debated back and forth. The meaning of these things were debated back and forth. And I think personally, some of that tradition seeped into the Jewish consciousness of scientists that were Jewish, and great Jewish scientists in history. They had this kind of dissatisfaction with the status quo. Einstein being, prototypical, Feynman being another one. They were anti-authoritarian. Which is interesting, because the word, we don't think about people that are Jewish and practicing as Jews do. We don't think about them, as saying, oh, well, I'm going to do whatever I want. I don't like authority. The ultimate authority is God, after all, at least if you're a believing religious practitioner. So, but actually the word Israel, you may not know this, means to struggle against God. So it's really the tradition of Judaism is fighting against authority. And I think that that's a beautiful thing for science to take into account, that you don't accept anything on blind faith in science. You argue against it. Even Einstein, even Feynman were wrong. And you can be unafraid to pursue your own ideas because there's no God of physics. And so I think you're right. I think there is an influence of the Jewish tradition of learning and exchange that is imprinted on Jewish scientists.
Well, very fascinating. Thank you very much. I wish we could cover so much more. I want to respect your time. One final question. If you could tell us, do you have a preference for any particular interpretation of quantum mechanics and or theory of everything? Where do you feel like this is going?
I think, controversial, I am at some level the kind of Copenhagen shut up and calculate school, where I like to get results in terms of the interpretations of quantum mechanics. I know it's incomplete. There's something about many worlds that's unappealing to me. The fact that it seems to be untestable. Although I did an interview with Sean Carroll on my podcast, Into the Impossible, and you can find it on YouTube under Dr. Brian Keating. He was trying to make some cases that you could actually establish experimentally the existence of many worlds alternatives. But I didn't find it particularly convincing at the time. I confess I haven't looked as deeply into it as I could. So I think about it, but it's not something I think about quite as much as people like Sean Carroll or Adam Becker or other people. On the other hand, I'm very interested in theories of everything, with the expectation that there's no guarantee to find a theory of everything. That doesn't preclude us from looking. So I'm actually working with Eric Weinstein. He's been to UCSD, where I am in San Diego, and we've been talking about collaborating and mentoring students. And if people want to help, they can help us, do things like, kind of learn more about his theory of geometric unity. I'm trying to get him to actually write something up to illustrate something about geometric unity on the web. And we'll have to see if he actually goes through with it. But if anybody has anything on the web, leave it in the comments section below. If you can do some illustrations or of some of the advanced concepts that Eric has. And Stephen Wolfram has a complementary approach, but which involves things that more akin to neural networks or to these Conway diagrams, et cetera. But it's not clear. So my feeling is, let's let 1,000 flowers bloom.
Very interesting.
Thank you very much, Luis. I'm going to have to run to the laboratory, but it's been great talking to you. Let's keep in touch, and can't wait to see where this goes from here. We'll do a part 2.
Thanks so much for your time. Have a great day.
Thank you, Luis. Have a great weekend. Bye-bye.
If you like what you heard, stick around and let's reason together.